Ancient butt drag. Fossil reveals secrets of Pleistocene Hyraxes. Ancient butt drag. Fossil reveals secrets of Pleistocene Hyraxes, a remarkable discovery on the Cape South coast of South Africa, has yielded the world's first fossilized butt drag impression, left approximately 126,000 years ago by a relative of the modern rock hyrax, also known as daces. This unprecedented finding, along with what appears to be a fossilized track site, offers a unique window into the lives of these furry, thick-set creatures and the environment they inhabited during the Pleistocene epoch, roughly 2.58 million to 11,700 years ago. What are rock hyraxes, and why do they drag their butts? Rock hyraxes are familiar inhabitants of southern Africa, often seen sunning themselves on rocky outcrops. These creatures are known for their short legs and lack of a tail. Interestingly, they sometimes drag their hindquarters across the ground. While dog owners might associate this behavior with parasitic infections, the reason in hyraxes is less clear. However, this action leaves distinctive marks in sandy areas, traces that are now incredibly rare to find fossilized. A treasure trove of fossil tracks along the Cape Coast. Researchers at the African Center for Coastal Paleoscience have been studying fossilized tracks and traces along the Cape South coast for decades as part of the Cape South Coast Ichnology Project. Their efforts have uncovered nearly 400 vertebrate track sites, some dating back 400,000 years. By studying these ancient impressions, scientists are piecing together a detailed picture of the environment and how animals and plants lived during the Pleistocene. The groundbreaking discovery. A butt drag and possible track site among the latest finds are two significant fossilized traces. One is a probable track site, located near Walker Bay and estimated to be around 76,000 years old. The other is the groundbreaking butt drag impression, found east of Still Bay and dating back roughly 126,000 years. The butt drag impression is a globally unique find, and along with the probable track site, represents the only potential fossilized hyrax tracks ever identified. Interpreting the fossilized impression using a technique called optically stimulated luminescence, researchers dated the sand samples to determine when they were last exposed to sunlight. The butt drag impression itself is 95 cm, 37.4 inches, long and 13 cm, 5.1 inches wide, featuring 5 parallel striations. Its outer edges are slightly raised, and within the impression sits a distinctive raised feature, a 10 cm by 9 cm, 4 by 3.5 inches, mass standing 2 cm, 0.8 inches high. While initially considering possibilities like a leopard, an ancestral human dragging prey, or even an elephant dragging its trunk, the researchers concluded that these scenarios couldn't account for the raised feature. The most plausible explanation is that the impression was made by a hyrax, with the buttock trace wiping out any preceding tracks, and the raised feature potentially representing a fossilized mass of hyrax droppings, known as a coprolite. More than just tracks, hyrax urine and hyraceum, rock hyraxes leave behind a surprising variety of traces beyond just tracks and butt drag marks. Their preference for rocky areas often leads to the polishing of rock surfaces, creating a shiny finish similar to buffalo rubbing stones found on the North American prairie. They also produce unique deposits of urine and dung. The concentrated urea and electrolytes in their urine, combined with large amounts of calcium carbonate, create extensive whitish deposits on rock surfaces. These deposits often mix to form a rock-like mass called hyraceum, which has historically been used for medicinal purposes. Hyraceum deposits can be tens of thousands of years old and are considered a threatened, non-renewable resource. Appreciating the significance of hyrax traces, scientists are now advocating for a new understanding of these often overlooked traces. While fossilized urine is rare globally, it is formally recognized as urolite, distinct from coprolite. It appears that hyraxes contribute significantly to the world's supply of urolite. By appreciating the importance of butt drag impressions, urolites, coprolites, and hyraceum, researchers can gain a deeper understanding of Pleistocene environments and the intriguing lives of rock hyraxes. Ultimately, these discoveries challenge us to view these endearing creatures in a new and meaningful light.